So escaping from a gravitational field is actually a bit of a tricky thing. What something needs to do, for example, a rocket, it needs to have enough kinetic energy to overpower the gravitational energy of the Earth or whatever planet is holding it down. This is a big issue when we start to discuss traveling to other planets, the Moon, Mars, for example. But when we launch a rocket, it will run out of fuel, and one of three things will happen. It may fall back to the Earth if the kinetic energy developed by the rocket is less than the gravitational energy of the Earth. It could go and remain absolutely stationary, and that works if the kinetic energy is exactly the same as the gravitational potential energy. This is called a geostationary orbit. This is where all of the GPS satellites are located. They stay in the same spot. They don't move away from the Earth or towards the Earth. That would be a bad thing for GPS satellites. Or the rocket could continue moving away from the Earth forever if its kinetic energy is larger than the potential energy of the Earth. So talking about escape velocity, how fast does the object need to be going in order to escape the gravitational field? We have this formula, and I want to know what is the escape velocity of an object leaving the Earth. So what is VE? In order to use this equation, we need G, look it up as we always have, 6.67 times 10 to the minus 11 Newton meters squared per kilogram squared. The other two factors are the mass, not of the object, but of the place the object is leaving. That would be the Earth. Looking that up, 5.98 times 10 to the 24th kilograms. And we also need the radius of the planet we're leaving. That would be the Earth. Looking that up, 6.38 times 10 to the 6th meters. Substituting that into the equation, which is VE equals square root of 2gm over r. We have 2 times 6.67 times 10 to the minus 11 times 5.98 times 10 to the 24th. That is over 6.38 times 10 to the 6th. Working that out, we can do that in one step. We get an escape velocity to 3 sig figs of 11,200 meters per second. Or, more commonly in kilometers per second, it would be 11.2 kilometers per second. What this means is that as soon as any object goes faster than 11.2 kilometers per second away from the Earth, it will continue moving away from the Earth. If it doesn't get to 11.2 kilometers per second, it will eventually fall back down. If it hits exactly 11.2 kilometers per second, it will end up in what's called geostationary orbit, which we'll look at in the next example.